Despite many gaps in historical knowledge, learned historians assert that humanity's past is generally well documented through known events that occurred across various countries and cultures. These events encompass sequences of rulers, the lives they led, their writings, and entire dynasties. Additionally, scientists employ numerous methods to clarify the details and dates of these events, even uncovering previously unknown historical pages. Historians believe that history, as a science, primarily relies on historical documents, archaeological finds, and preserved objects of material culture. While this is largely accurate, it's not entirely straightforward. As demonstrated in the second film of our series, nearly all traditional dating methods have significant flaws and limitations. When determining the age of artifacts and material items using these methods, errors can range from hundreds to thousands of years. Such instances of incorrect dating are numerous, making the traditional chronology of historical events questionable. Consequently, history itself may be largely myth, fiction, or novel, and humanity knows much less about itself than commonly thought. So, how can we uncover the real history of mankind and get closer to the truth? Let's explore a discovery from the 1970s. Russian mathematician Anatoly Timofeyevich Fomenko, while working on celestial mechanics, encountered an intriguing scientific work by Robert Russell Newton, an American astrophysicist and head of NASA's Computing Center. Newton was developing space navigation networks based on dates of lunar eclipses from ancient chronicles, starting from 370 BCE. His calculations provided a complete understanding of the moon's movement, documented in his scientific works. Fomenko found that Newton's research indicated radical changes in the moon's movement from around 800 BCE to 1000 CE, where the moon's speed increased and then slowed back to normal. This phenomenon could not be explained by Newtonian mechanics or modern gravitational theory. Newton concluded that an inexplicable force must have caused these changes, but he couldn't identify this force. Discussions organized by the British Academy of Sciences in 1972 failed to resolve this issue. This challenge intrigued Fomenko, who decided to investigate further. While Newton's calculations appeared accurate, his conclusions seemed strange. Ultimately, the solution was found in an unexpected place: the solar and lunar eclipse dates that formed the basis of Newton's calculations. In the famous seventh volume known as Christ, I asked to bring this book home. It contains tables that detail eclipses based on new dates proposed by Nikolai Morozov, covering antiquity and the early Middle Ages. Newton's algorithm but replaced the original eclipse dates with Morozov's new dates. Upon repeating Newton's calculations, the strange variations disappeared, and constants remained stable over time. This indicated that there was no need to invoke mysterious forces affecting the Earth-Moon system. This revelation solved a significant problem in celestial mechanics and marked the beginning of a major scientific study. Anatoly Fomenko, after meticulously studying the dating methods used by historians and archaeologists, and examining all of Morozov's works, concluded that not only were ancient eclipse dates incorrect, but other information in historical chronicles might also be false. To verify this, he had to start from the basics. The traditional chronology was proposed by the French philologist Joseph Scaliger in the late 16th century, who synchronized the chronologies of different cultures using astronomical dating based on eclipses. However, nearly 4 centuries later, Fomenko discovered that this method was flawed and used incorrectly, prompting him to develop new, more accurate dating methods to recreate the true chronology of world history. Naturally, Fomenko faced opposition, especially from historians who argued that dating and documentary evidence fall within the realm of history, not mathematics. However, chronology, as a science, originated in the 16th century and was part of applied mathematics. Astronomical calculations and the assessment of their accuracy were tasks for mathematicians. In the 20th century, the verification of these calculations was also done by mathematicians. Fomenko began his work in 1973 and spent 8 years developing new dating methods. Initially working alone, he later gained like-minded colleagues, which accelerated the progress. With the support of his collaborators, Fomenko successfully developed and refined new mathematical and statistical dating methods. Notably, he worked with mathematician Gleb Vladimirovich Nozovsky, and together they created new methods starting in 1981. They collaborated with Kalashnikov Vladimir and Fomenko's wife, Tatyana Nikolava Fomenko. Although Kalashnikov is no longer with us, the work continues with Fomenko and Nozovsky. The mathematical methods developed by Fomenko, Nozovsky, and Kalashnikov are precise scientific tools that can verify historical documents, chronicles, maps, and royal biographies. These documents can be formalized into statistical units and thoroughly analyzed using multiple methods and tools. To understand these unique methods, you don't need to be a mathematician. We will simplify our explanation to highlight the main points of these methods without delving into complex formulas and calculations. Is it possible to compare different texts? Certainly, everyone can agree that each text has a specific meaning. However, comparing historical documents, such as chronicles from different eras and countries, reveals a more complex picture. At first glance, these chronicles may describe entirely different events, but what if they are actually recounting the same historical incident? It turns out this is possible, but how can we recognize it? Determining whether texts are interconnected requires more than subjective judgment, as personal biases and stereotypes can cloud objective evaluation. So, how can we objectively check whether texts describe the same period or different ones? Often, two descriptions might appear entirely distinct, but mathematical analysis can reveal surprising similarities. Consider having two unknown keys. The easiest way to determine if they are the same is to insert them into a lock. If that's not possible, one might compare their tooth profile patterns. Similarly, texts can be compared by transforming each into a graph. Every historical text describes events in a certain sequence, typically by year. This allows us to segment the text by year, then quantify the material for each segment by counting pages, lines, or characters, thereby obtaining a numerical representation of text volume. On a graph, the x-axis represents the years, and the y-axis represents the text volume for each year. By plotting these data points, we create a visual representation of the text. Creating similar graphs for two texts results in two lines with peaks, local maxima, indicating significant events. The correlation method involves comparing these peaks to see if they align. The peaks is less important than their positions on the time axis. If the peaks coincide, the graphs, and therefore the texts, are likely describing the same events. This method has been tested on numerous texts and consistently proven effective. For instance, comparing texts on Roman history by the ancient historian Titus Livius and Soviet historian Vladimir Sergeyev shows synchronized peaks, confirming they discuss the same events. Using this method, we can analyze chronicles that supposedly describe different events and are dated centuries apart. For example, consider the tale of bygone years from the 10th–11th centuries and the Chronicle of Nicephor from the 14th–15th centuries. Historians assert these documents are separated by nearly 400 years and describe different events. However, their graphs unexpectedly coincide. Dry mathematical calculations suggest they refer to the same historical period, indicating a potential dating error of 300 to 400 years in one of the documents. Such examples are numerous, demonstrating that only through mathematical and statistical methods can we objectively analyze old texts. If the outlines of the keys match, the logical conclusion is they open the same lock, regardless of attempts to convince otherwise. In this way, the truth becomes evident through material evidence. Ancient geographical maps can reveal a wealth of interesting information. These maps represent humanity's understanding of the world at various points in time. Initially, they were primitive schemes, but as navigation developed, wars were fought, and trade relations were established, new information about lands and countries was integrated into these maps. As a result, maps from each era became increasingly accurate. For example, a rare map from 1522 shows Europe and Asia in a form very different from modern maps, with Greenland depicted as a peninsula, the Black Sea oriented vertically, and an unrecognizable Caspian Sea. China is entirely absent. The map by Cornelius Nicolai from 1598 also suffers from distortions, but there are fewer inaccuracies compared to earlier maps. Another example is a unique globe created by the famous Dutch company Bleu at the end of the 17th century for Swedish King Charles XI. This globe, much closer to reality, shows more accurate outlines of continents and includes many newly discovered lands. This progression demonstrates that each subsequent map reduced the amount of incorrect geographic information and increased the correct details, similar to how children's drawings become more realistic as they grow older. Visual comparisons of geographical maps can provide insights, but for serious research, this is insufficient for scientific validation. Anatoly Fomenko developed a method called the method of correct chronological ordering and dating of ancient geographical maps. For instance, consider several ancient maps: the Cartouches map, believed to be from 1493, Peter Apian's map, circa 1520, Cartus Linus's map, 1538, and a map from Mercator's Atlas, 1607. Each map is assigned a serial number based on its official date. To analyze these maps, a table is created, detailing whether the map is flat or a globe, world or regional, and noting the positions of poles, the equator, climatic zones, seas, and countries. Fomenko called this table of geographical features a map code, a formalized model of the map. Similar tables are compiled for other maps selected for comparison. This information allows us to plot a graph, with the horizontal axis representing the serial number of the map and the vertical axis representing the number of incorrect geographical features. Each new map shows a decrease in incorrect features and an increase in correct details, such as accurate coastlines. The total number of anomalies decreases, resulting in a downward curve on the graph. When this method was applied to maps from antiquity and the early medieval period, the dating often contradicted modern historical understanding. For example, Ptolemy's maps, traditionally dated to the 2nd century AD, appeared to fit the geographical knowledge of the 15th century. Maps, like those attributed to Hesiod and Euclid, also seem to align more closely with the 12th and 13th centuries AD rather than their supposed ancient origins. The famous map by Hans Reus from 1480, though beautiful, reflects the cartographic development of the 15th century. In contrast, maps attributed to Ptolemy, supposedly from the 2nd century AD, align with the geographical understanding of the Columbus era. This suggests that detailed, high-quality maps may have been created much later than traditionally believed, challenging the conventional timeline of cartographic history. Then, suddenly, I lost all my knowledge and skills and reverted to primitive methods. However, humanity did not experience any global catastrophes, and its development did not cease. The new generation did not have to rediscover the world from scratch. So where did these supposedly ancient, highly realistic geographical maps come from? This paradox in the development of cartography baffles historians, but Fomenko's method of ordering geographical maps provides an explanation. His method calculates the true time of the appearance of these so-called ancient maps, showing they were created no earlier than the 15th and 16th centuries AD. This suggests that traditional chronology contains not just minor errors but significant mistakes spanning hundreds or even thousands of years. It's implausible to believe that a child, who had just learned to hold a pencil, could draw an accurate, vivid portrait and then revert to drawing crude tree branches and disproportionately large flowers. Most likely, the sequence of drawings got mixed up, which is the only logical explanation. Historians have long believed that chroniclers sometimes attributed the deeds of ancient kings to their contemporary rulers. Traditional history claims this practice was widespread in ancient times, resulting in many similar biographies of ancient rulers. Identifying these repetitions requires more than just studying a large number of historical biographies. The information must be systematically organized. To address this, Anatoly Fomenko developed a questionnaire-like table, which he called the Code. This code can be applied to any chronicle biography, allowing it to be studied independently of subjective assessments. The code consists of 34 points, detailing information about rulers, including their gender, lifespan, reign period, status, emperor, commander, religious leader, cause of death, natural disasters, astronomical phenomena, conspiracies, wars, and other significant events during their rule. Fomenko meticulously created codes for several hundred major ancient rulers. Comparing any two codes reveals similarities or differences. This method allows not only for the comparison of individual biographies but also entire dynasties. For instance, if we select 20 sequential kings from two dynasties, we can compare their codes. Fomenko calls this sequence a flow of questionnaires. The comparison begins with the first ruler of each dynasty, then the second, and so on. It's important to note that finding similar biographies doesn't automatically imply the same historical events. To determine the degree of similarity between two dynasties, Fomenko developed a special coefficient, allowing for a graphical representation of the comparison. By plotting the serial number of each ruler horizontally and their reign period vertically, Fomenko creates a dynasty profile. This profile is unique and can be used to identify any ruling family. When profiles of two dynasties show little difference, it suggests they depict the same real dynasty. Fomenko's method, based on the principle of minor errors, posits that chroniclers' mistakes in the duration of reigns were minimal, making the profiles derived from chronicles highly individual. Just as each person has unique birthmarks distinguishing them from others, each dynasty profile is distinct, allowing for accurate identification even across different periods. Names, biographies, and documents may differ outwardly, but superficial changes like hair color, added mustaches and beards, or even plastic surgery cannot alter DNA and fingerprints, which are unique and individual. With a sufficient database, it is always possible to identify the person behind a new appearance and name. Mathematically calculated dynasty profiles are akin to fingerprints or DNA. A supposedly unknown dynasty is found in a historical document. Its profile can be recreated and compared with those in the database. The graph below illustrates profiles of the ruling dynasties of ancient Judea, 6th–1st centuries BC, and the Eastern Roman Empire, 4th–7th centuries AD, as well as the medieval Holy Roman Empire, 10th–13th centuries, and the medieval Habsburg Empire, 13th-17th centuries. When these profiles are aligned differently, they appear almost symmetrical, suggesting they belong to the same dynasty. To verify this visual similarity, the probability of these pairs of dynasties coinciding by chance is calculated and found to be minuscule, about 1 in 100 billion. This implies that many seemingly different dynasties, living in different countries and eras, are actually dynastic twins. Official history has numerous such dynastic duplicates. In cases where dynasties are officially considered different, one ruling in ancient Rome and another in medieval Europe, this method has shown that their ruling schedules are strikingly similar. Such pairs are known as duplicate phantoms, and there are dozens of examples. This method reveals that some ruling dynasties were merely duplicated in history, solely on paper. This could have happened due to two reasons. First, errors might have occurred due to the underdeveloped science of the time, where interpreters of old documents describing the same dynasty thought they were about different rulers, giving them new names and moving them to other countries and eras. Second, more importantly, powerful forces in the Middle Ages may have deliberately rewritten history to conceal significant information for their descendants and other peoples. This will be discussed in detail in subsequent films. The discovery of duplicate dynasties leads to new insights. Not all chronicles reflect events in the actual chronological order they happened. Chroniclers, while describing events, focus on kings and significant people of their era, ensuring they accurately document their heroes. Thus, characters' actions serve as key guides when analyzing texts. A person's diary can reveal much about the owner. For example, a boy's diary might show frequent mentions of a friend, Masha, during school years, which decrease as he moves to college and makes new friends, until her name disappears entirely after he starts working and forms a family. This same logic applies to chronicles. Each generation gives birth to new heroes, so chroniclers, when moving from one generation to another, include the main characters of their stories. This simple principle is useful for dating methods. To check the accuracy of a chronicle, construct a chronological order of events, marking the sequence of text parts horizontally and the number of messages about historical figures introduced in each part vertically. If the events are described correctly, the chronological order curve on the graph will decrease. This method, called the principle of frequency attenuation, has been repeatedly tested and confirmed with historical documents from the 17th to 20th centuries. However, turning to earlier chronicles begins a new investigation. Graphs of ancient chronicles, constructed using Fomenko's methods, often reveal startling patterns. Instead of a smooth, decreasing curve, they frequently display broken lines with unexpected spikes. This suggests that long-forgotten historical characters reappear with the same frequency, indicating not historical errors but parts of the chronicle mistakenly placed in the past. Restoring these parts to their correct position results in a proper descending curve. Imagine the last page of a diary suddenly discussing long-forgotten school friends. This doesn't mean Petya has forgotten everyone around him from later years. More likely, a page from the beginning of the diary was misplaced at the end. Similar examples illustrate how historical records can become jumbled, necessitating a thorough review of accepted history. To see all the contradictions in the traditional historical narrative, it might be essential to create a comprehensive chronological map of history. Though daunting, Anatoly Timofeyevich Fomenko found this task achievable. Fomenko undertook extensive research to uncover the true course of world history. He analyzed hundreds of ancient texts, chronicles, and documents detailing key events across 6 millennia, from 4000 BC to 1900 AD. To present his findings clearly, he created an unprecedented document, a massive timeline extending along a horizontal time axis. Exact dates based on the traditional historical accounts of Scaliger and Petavius. This timeline, initially plotted on graph paper, was scanned and printed on special material, resulting in a unique 19-meter-long document. This timeline graphically represents the history taught in schools and universities, distributing tens of thousands of dates and information from primary sources and chronicles. Using his methods, Fomenko marked identified duplicates, creating a comprehensive map that revealed repetitions of historical events across different periods. He divided world history into eras, depicting events from different countries that occurred simultaneously, highlighting the repetitions within traditional history. For instance, Fomenko assigned the Roman Empire the letter K and marked all duplicates of this era with the same letter. Other historical eras and their duplicates were designated with different letters, such as S and P. This structured map, known as the Global Chronological Map, illustrated how historical events replay across the time axis. It became evident that traditional history contains 3 major temporal shifts of approximately 300, 1000, and 1800 years. Many genuine medieval events were inaccurately reproduced by chroniclers and wrongly placed in the past. This raises the question, How could medieval chroniclers have made such significant errors unintentionally? Let's take 4 ancient chronicles, each describing events in 15th century Europe. The authors of these chronicles, however, lived in different countries and times, spoke and wrote in different languages, and used varying chronologies. Consequently, the same kings, cities, and battles were given entirely different names. When 16th and 18th century chroniclers read these accounts, they mistakenly believed they were about different eras. Instead of placing these chronicles one above the other on the timeline, they arranged them sequentially, with one chronicle left in the 15th century, another pushed back 300 years, a third by 1,000 years, and the fourth by 1,800 years. This resulted in an excessively long historical timeline. Using Fomenko's methods allows for objective analysis of old texts and maps, avoiding the subjective interpretations that traditional chronology relied upon. Until mathematical methods from astronomy were applied, history remained subjective and unscientific. Fomenko and Nosovsky's New Chronology project consists of 2 parts: new mathematical methods for analyzing old texts and maps, and a newly compiled chronological map. This map was created by cross-checking ancient texts and maps using developed methods. The second part involves a speculative reconstruction of history based on this new chronological scale. Anatoly Fomenko and Gleb Nosovsky realized the need to recreate all of world history, as traditional history is based on incorrect chronology. Supported by other prominent researchers, Fomenko's work began to attract attention both in Russia and internationally. In Germany, similar research was conducted by mathematician, historian, and writer Evgeny Gabovich, who further developed Fomenko's theories. This chronological revolution aims to transform history from a collection of philological, ideological, and virtual narratives into a true science of the past. Alexander Alexandrovich Zinoviev, a distinguished Russian philosopher and writer, became an ardent supporter after reading Fomenko and Nosovsky's work. He described his reaction as shock and profound admiration, recognizing Fomenko as one of the most brilliant scientists of the 20th and 21st centuries, comparable to figures like Giordano Bruno and Galileo. The new chronology, with its systematic analysis and scientific methods, presented groundbreaking results. Fomenko and Nosovsky's methods helped answer previously unsolvable historical questions and revealed unknown historical facts. For instance, it was discovered that Russian history had been radically altered, with European and Asian chronologies artificially lengthened, while Russian history was significantly shortened and distorted. Fomenko's methods also established that many well-known historical figures never actually existed. It turns out that many historical events and figures we believe to be real are actually phantom doubles, while others are genuine historical personalities. Sadly, humanity has been dealing with a significant historical hoax for many years. Events that supposedly occurred before the 10th century AD are phantom mappings of real events from the Middle Ages, specifically between the 11th and 18th centuries. These were incorrectly dated and presented as genuine past events. Consequently, the work of the authors of this project, who propose new chronologies, holds enormous scientific significance. I believe this is one of the greatest discoveries of the 20th century and the most significant in the field of historical research. It shapes our understanding of humanity's true history. We will explore the theories of Anatoly Fomenko and Gleb Nosovsky in detail in our upcoming films in the popular science series History, Science or Fiction? The revelations are amazing, unexpected, and may even seem shocking to some. Ancient civilizations left us not only numerous historical monuments but also many riddles. One such riddle is the Egyptian pyramids. How were these majestic structures built? Ancient architects managed to process and move huge stone blocks. Are the secrets of ancient Egypt real? This mystery remains unsolved. We will delve into this topic in our next film, The Alchemy of the Pyramids, How They Were Built in Ancient Egypt.